Hi everyone, and welcome to workshop number 3 of our Attack Detection Fundamentals series. This week we're covering some more cloud focused techniques. So we're back in AWS now. I am thrilled to say that I'm joined by Nick. Nick and myself are both senior security consultants within SQ Consulting. Nick leads up our global cloud team, as I lead up our global attack detection and kind of all things purple. So I'm just going to give a brief recap on the goals of this series, what we're hoping to achieve. If you've seen one of these before, then hopefully you're pretty well versed in what we're here for. So we've taken some kind of discrete attacker actions, and our plan is to kind of show them to you, do them in a controlled manner so that we can look at how we might detect and maybe even prevent them. The idea is that much of what we're going to show you in terms of the techniques and the telemetry are sources or techniques that could exist within your enterprise products that you rely on day to day, but this hopefully gives you a little bit of insight into kind of how they might work. Obviously, much of what we're going to show you are logs provided by AWS, so some of that is less relevant this time, but the premise is still relatively the same. In terms of kind of how we're going to do that, as I've said, we'll analyze the TTPs, understand kind of what they do, how they work, how we can emulate them. And we're going to do this in a simple controlled lab environment. Obviously, things are slightly different this time around because we're doing things not on a single endpoint like our Windows or Mac OS workshops. So we'll cover off exactly how we're going to do that in a few slides' time. But ultimately, we're going to look at the traces that we leave behind by performing these actions and see what we can do with those. So, as I said, the premise is the same as always. Simple lab setup, so hopefully something that you can spin up quite quickly to kind of demonstrate and walk through the guides that we provide. Just as with all the other workshops, there'll be a recording of this session available most likely tomorrow. Similarly, the lab guides will be available imminently, if not already, and similarly the PDF of this will also be available as well, so you can go through this, wind back the recording, go through step by step and digest it kind of at your leisure. Just as before, much of what we're going to be talking about this week, both in terms of the kind of techniques, but also the tooling we'll be using, is influenced and inspired and heavily kind of used by the wider industry. And in particular, I'd just like to take a moment, as last week, Spencer Gutson sadly passed away. Much of his tooling and his research are things that both Nick and myself have been heavily influenced by. So I just want to extend our sincerest condolences from me, from Nick, and from the rest of F-Secure to his friends and family. So where we're up to then, we've got our 4 workshops just as before. We covered Windows and Mac OS in the previous 2 weeks. We had myself and Ricardo, followed by Callum and Luke giving the Mac OS workshop, and now we're on to AWS. So we'll cover that off today, and then we'll be rejoined with Sunday for the final week to go through some Azure. So workshop 3 then, Azure, AWS. It's not uncommon for us to hear this something along the lines of, oh yeah, we got some AWS workloads, we should probably log some stuff in there, or maybe a little bit better, we are logging stuff and it's going into an S3 bucket, and maybe one day soon we'll look in that bucket and see what's going on. I think the important thing to take here is that cloud is, and it's probably not a surprise to anyone on this workshop, is that it is a huge market, and AWS has a majority share in that market, and it's indeed still growing. And I think the long and short of it is that we'll continue to see more and more critical workloads in cloud and within AWS. And so making sure that we have some kind of mature detection and response capability within that is obviously going to be more and more important. So I saw this tweet while we were preparing for this workshop, which I thought was pretty apt. An AWS Security Talk starter pack, and several of the things on this list we are inevitably going to cover off. So talk of public S3 buckets, the shared responsibility model, and attack, and indeed Capital One are all kind of things that we might touch upon. So hopefully we've gone through the right motions there. So just to drill into it a little bit in terms of things that we're going to be covering. So 4 key concepts. The first one is, I guess, just a bit of a primer. For those that have come off the back of more on-premise kind of detection and response, they've kind of maybe joined the Windows and Mac OS workshops we've run previously. I think it's fair to say that there's a change in kind of mindset, if you like, when it comes to detection in the cloud, and the workloads that we're talking about could be very different and maybe have no kind of equivalent to something we might see on premise. So we're going to cover off a little bit of that, as well as the log sources that we can use to kind of keep up with all of that. And then we have the 3 stages of our kill chain. So as you might remember in previous workshops I've mentioned, we'll try and cover several steps of a kill chain rather than just focus each workshop on a single part of the kill chain. So we're going to cover off initial access and reconnaissance based on the keys that we'll produce. Obviously for us, we'll provide our own AWS API keys, but obviously in a real circumstance, things might be quite different. We'll then cover off some persistence techniques, cover off kind of how that could be achieved, both when it comes to maybe an EC2 or virtual machine persistence, but then kind of thinking more widely in terms of, as we'll talk about, the control plane opportunities that might exist there. And then finally, data exfiltration. So I think it's fair to say that the objectives of attackers, I guess, most prominently in the news and the media, as you'll see, are largely around kind of crypto mining, so taking those AWS access keys they might find in Git or the like, and then deploying kind of high-powered crypto miners to make some cash off of that access. But we'll take a little bit of a different look and look at some data exfiltration. We have 3 labs, just as before, and they'll cover off that scenario, going from initial access, understanding where we are, who we are, what we can access, installing some persistence, and then exfiltrating some dummy customer data from an S3 bucket. So I'm going to pass over to Nick now to talk about detection in the cloud, how things might have changed for us.
Thanks, Alfie. So yeah, there's quite a lot really that changes actually when it comes to detection in the cloud. And I think one of the easiest ways to illustrate that is to talk about the typical attack paths that people take when they're targeting both on-premises and cloud environments. So first off, if we look at some sort of legacy on-premises networking, typically someone would, or an attacker rather, would come in and either attack perimeter assets, things like the Pulse Secure VPN 0 days that we're seeing a lot of lately, or perhaps more commonly initiate a phishing campaign, get a foothold, do some lateral movement and privilege escalation within the internal network, and then eventually actions on objective. Now, if we look at the cloud, none of that really goes away. What we have instead is a whole load of additional complications, because now an attacker can directly target cloud assets, either in terms of perimeter exposed systems or systems that have been, or assets that have been accidentally open to the public, perhaps is more apt in the cloud. But we can also still target the on-premises estates the same way we always did. And in fact, one of the really interesting ones at the moment are these golden SAML attacks you hear people talking about. And what they are at their core is exploitation of a single sign-on platform to gain access into the cloud from a compromised on-premises network. So there are a number of links typically between people's on-premises and cloud networks, and it's often possible to start in one and move into the other, or hop between different cloud environments. So there's a lot more complication here, I think, than in a typical on-premises breach. And if we look at how we can detect all of this in terms of the telemetry that's available to us, first off, you've got all of the usual things that we used to have. If you're running virtual machines in the cloud, you've still got all of your host-based telemetry. You can run your EDR, you can ingest your syslog and your Windows event log and so on. But what we lose as we get more towards the serverless and sort of hipster cloud native end of things is all of the operating system level visibility. There are ways we can adapt for that, which we'll get into in a bit, but that host telemetry is still fairly important. Likewise with network telemetry, where we're running workloads inside networks rather than leaving them to run on the cloud provider's own infrastructure wherever. And lastly, application telemetry, also very important. But the new thing here, which really is the critical piece, is the control plane telemetry. And what that represents is a log of all actions taking place at the cloud control plane level, so at the level where we're creating and deleting and modifying individual cloud resources, virtual machines, IAM users, all of these kinds of things. So if we look at some of the log sources that we've got available, the two big ones really when it comes to talking about log sources in the cloud are your control plane audit logs and your service specific logs in terms of new stuff you've not come across before. Most of the rest have their on-premises equivalents or are basically the same, EDR, for example, syslog, so on. And cloud-native detection services like Guard Duty for AWS are essentially not that far off perhaps some of the detection systems that you might be used to working with. It's a bit like dark trace, it's that kind of thing. And we'll catch some stuff, maybe not catch others. But we're going to dig a bit into the control plane audit logs and the service specific logs now. So first up, CloudTrail is your primary log source in AWS for anything happening at the control plane level. If you turn on one log source and one log source only, this is the one you need. And I wouldn't be moving into the cloud personally if I didn't have a way of monitoring CloudTrail sensibly. So this will track any creation, modification, deletion of resources. It will also track read-only events, so enumerating resources, listing things, getting configuration details for different assets, all of these kinds of things. And that really is key if you want to spot what an attacker's doing inside a compromised cloud account. And then when it comes to specific services, many of them also offer a set of logs of some sort for monitoring what happens inside them. So for Lambda, serverless functions in AWS, there is the Lambda execution logs, which say what function was triggered when, by what, with what parameters, and so on. Likewise, DynamoDB now, as of a month or two ago, allows you to track reads and writes from Dynamo. You've got your S3 object level and access logs that you can enable. And so we can take advantage of all of these as well. However, there is a downside to just turning it all on and letting it all flow in. You don't necessarily want to drown yourself in that log data because a lot of these will be really quite noisy. So what we typically recommend is to look at the value in each individual resource, what it would mean for an attacker to breach it and what they're likely to try against it before deciding what logs to gather from it. So take an S3 bucket as an example. If the S3 bucket contains all of the bank statements for an online banking system, that's probably a really key one to monitor. Equally, if you have a S3 bucket that is simply there to serve static content, CSS, HTML, things like this for your website, then monitoring who's reading from it really doesn't matter. But what you might well care about is monitoring who is writing to it, because actually if you have a user who is writing to your bucket that's containing all of your JavaScript, they might be trying a Magecart style attack on things, and that's obviously really not good. That's not what we want at all. Then going on to talk a little bit more about EDR in detail. What actually happens here is that we need everything we always needed. If you've got virtual machines running in the cloud, you still need your EDR because there's a bunch of stuff that you'll miss if you don't have it. You need your in-memory visibility of what processes are doing, all of these kinds of things. And then there's a number of other log sources like VPC flow logs, which are roughly analogous to things that you were doing previously on premise, like Cisco NetFlow analysis, for instance. So worth considering all of those as well. Basically, don't forget the useful stuff from before just because you're moving to the cloud. Now, when we look at the range of cloud services, we can split up these log sources, broadly speaking, by the as a service definitions. So the closer you get to infrastructure as a service, virtual machines, networks, the closer we are to just straight up normal on-premises detection capabilities, right? And the closer we get to the software as a service end of things, the more it changes. Now, right the way up at that software as a service end of things with GitHub, with Okta, with Circle CI, these kinds of things, at that point, actually, we're still trying to work out what we're spotting in there. Most of those providers, Circle CI, for instance, have a fairly good audit log source that you can ingest, but you'll need to go work out what the different event IDs mean and how that might map back to what an attacker is likely to do. And so that is both something that we tend to do on a bespoke basis for each environment we look at, but also something that would make for a nice research project for a few of those common products if someone wanted to find something to do with their time. And at this point, I'm going to hand back over to Alfie to talk about our lab environment.
Awesome. Yeah, thanks, Nick. So I guess, as I said, like unlike the Windows and Mac OS workshops we've done previously, we don't have a ready-made lab environment for us to do our testing in and to demonstrate some of the key concepts. So what we've provided alongside these lab guides is a set of Terraform scripts that will allow you to spin up the lab environment that we're going to use and demonstrate throughout this this workshop. So there's a link at the bottom there, and there's a link in the lab guide as well, so you can go and look at that at your leisure. Effectively, what we have here is a very interestingly named customer data management user. And we have a customer data bucket. So when you spin up this these Terraform scripts, so for those unfamiliar, Terraform is infrastructure as code technology, allows us to specify in code exactly the resources that we want to make use of. In our case, obviously, we're looking at AWS assets, and that includes everything from our IAM user through to the bucket that we've spun up and the data within the bucket, and then all of this other log kind of infrastructure that we're going to spin up as well. So just to cover it off, we'll go through it in more detail, both within the lab guides and later on in this workshop. But the customer data bucket is going to provide us with server access logs. And we're also going to make use of the S3 bucket data events as well for some comparison. And as well as that, the CloudTrail itself, all of those will make their way into a log storage bucket, and that's within the same AWS account, so you only need one account. Worth mentioning, I guess, that the best practice would state that the logs from your workload should be going into a separate account, maybe into a security account, or even better, into a dedicated logging account that security then reach into, rather than necessarily suggesting the opportunity that they could degrade that logging if a security person was compromised as well. So with that, all of that log information will be stored in your S3 bucket alongside the customer data one, and then we're going to use Athena to perform some SQL queries against both the server access logs and the CloudTrail logs as well. So you can do that at your leisure and look at kind of the wealth of metadata that's provided with each of the data events that come through. It's also worth mentioning that this is very much a vulnerable by design workload. So don't you go and use this in a sensitive AWS accounts. The customer data management user, as we'll see both within these video demos, but also in the lab guide, is susceptible to some serious damage. So be careful when it comes to using this and make sure you use it in an appropriate environment. So moving on then, initial access and reconnaissance then. Well, firstly, just going to spend a little bit of time talking about how initial access kind of happens. I guess it's slightly different, of course, to the Windows and Mac OS that we might have covered previously, although there is some overlap. So the first is kind of public storage. As we'll see, there's no shortage of data exposure that's been kind of, it continues to be shown to us in the media. And similarly, the web app vulnerabilities is one as well that I think is quite an interesting kind of cloud native concept, if you like, to take a look at. And then we've also got the standard things that I don't think you need any introduction when it comes to exposed credentials in GitHub. And indeed, some of the targeted attack types that Nick kind of alluded to before, maybe starting off with a targeted, like a spear phishing attack for an on-premise user, and then from their endpoints, we might look to pivot or kind of escalate our privileges to make our way into cloud. So that public storage thing, yeah, that's kind of a big deal, and remains to be a big deal. You can see a few things here. This is just me doing a pretty ad hoc Google of AWS S3 buckets, and you can see, they continue to be a prevalent cause for data leakage. And indeed, I've kind of broadened that search a little bit and just did a query for Elasticsearch databases, and just the same, you can see there are 20,000 of them, or over 20,000 exposed on Showdown that we can see. Not to say that all of those are vulnerable per se, but just to show you the exposure for those kind of services that may be there. And then something that we've already spoken about, that kind of the data events that we could use to log some of our S3 activity. I mean, I'd like to think that if you're kind of putting in the diligence to be thinking about how exactly you're going to log the data events that are taking place with your S3 buckets, that you're not having it hanging off on the internet. But at least this gives you some idea of things to think about when it comes to the actual logging that exists there. So some scenarios that Nick already mentioned, I think, when it comes to, if you're talking about static web bucket content or web page bucket content, is that something that you care about every single time it's read? Potentially you do. If you've got the the log storage capacity to deal with that, and you can see some meaningful kind of alerting or use cases to implement, then by all means that's available to you. But similarly, you might want to refine that down to write events on that web content bucket. And then obviously, if you start dealing with more sensitive data where any interaction is likely to be worth logging, then you can do the reading and the writing of that. And there's just a little screen grab there of some of the filtering that is available to you from AWS when it comes to what you do and don't log. So you can really drill down into this specific bucket or this specific prefix or the kinds of activities that I'd like to see in my log event. So you can really kind of make that work for you depending on your workload and depending on your appetite when it comes to the detection engineering component. What you can see here is a snippet of the CloudTrail configuration that's implemented within the lab environment, so the actual Terraform that's being used to provision that. So you can see that read-write type is specified as all. So all events that are taking place against our S3 bucket. So bucket for exfil is the name of our customer data bucket, or the variable for it at least. And we can see there that we're providing basically coverage for the entire bucket. There's no, within that values field, there's no subsequent thing after the / that says we only care about this folder, for example. We're saying, give me everything, all the reads, all the writes for every object, and we'll see the impact of that in just a moment. And then the web app vulnerability one is quite interesting because I think that's quite, as I said, like a cloud native kind of attack type. So the idea here is, for those unfamiliar, is that within AWS we have this concept of roles, which, as any kind of role-based access control would have, it specifies what we can and can't do as a user. And then that role is attached to an EC2. So rather than being attached to a given user entity, it's attached to the EC2. And then what we can use is the instance metadata service to basically make use of that role within our applications functionality. So let's say we have a simple web application that provides us with the information that's stored in the S3 bucket in the same account that our EC2 has access to. So we make a request. Our EC2 then reaches out to the instance metadata service and says, I need to kind of perform my normal role. And so with that, I need some credentials that align with that. Based on the fact that we have the role attached, it will provide those for us. And those session credentials we can then use to perform our activity. So our web application will have the ability then to reach out to the S3 bucket and perform the activities that it needs to do. And then from there, it can provide that data to kind of fulfill the request that's been put there by the user. Where this gets quite interesting is when there are vulnerabilities like server-side request forgery or SSRF, where effectively we can, if you like, induce an effect where we retrieve those credentials and they're actually provided to the end user. So by the end user, I mean to the person making the web request. So by doing that, what we've effectively done is exfiltrated those session credentials that should never have left the EC2. And we can then try and use them to access the resources that the web application would otherwise kind of act as the middleman for. This is interesting for a couple of reasons. One is if you take those session keys and they may be, in a simulated scenario, maybe over provisioned. So we might have the ability to start listing buckets and making kind of high privilege changes that we shouldn't do. That obviously opens up quite a significant vector for attack. If you were to take those credentials and use them on your own endpoints to kind of use them and impersonate that or the role that EC2 has, if you're using guard duty, it's likely that would flag. So seeing those session credentials being used from an endpoint that isn't our EC2 could lead to an alert there. And at the time of recording, if you take those credentials and use them on another EC2 outside of the target account, so you spin up your own malicious EC2, if you like, that won't be detected by guard duty. And it might be that you need to start thinking about that coverage when it comes to other ways to restrict access to the actual resources themselves, maybe using VPC endpoints and the like. Or is there other detection engineering that needs to be done to kind of facilitate for that? And my understanding is that there are detections coming out for that within guard duty, but to my knowledge, they're not present yet. And it's also worth mentioning critically that based on this kind of attack vector and the prominence of it, that in, I think, November 2019, AWS released the Instance Metadata Service version 2. So that actually kind of mitigates this issue as long as we only use this instance metadata version 2 and are configuration isn't such that we support version 1 and 2, because in which case we can effectively like downgrade, if you like, and still perform the attack as we did before. So quite an interesting one. We'll obviously focus on the S3 side of things for the narrative in our labs, but something worth looking at. And then, like an honourable mention for the stuff that we've maybe alluded to already, this idea of pivoting from on-premise. So the point I think we're trying to hammer home here is that don't consider your AWS accounts and your detection and response, and indeed your security of those accounts, to be in a vacuum, that it only exists within those accounts. If you're using, as an example, kind of pipelines to push your code, whether that's infrastructure as code or whether that's the web app components itself, the code kind of material there, if that's being pushed upstream down into the accounts, bear in mind that the trust boundary there is impact that could be done upstream that would lead to those resources being provisioned within the account that you're trying to protect. And similarly, if you're using a source of trust, kind of federated access, to go from your on-premise environment using whichever identity provider you care to mention, and then you pivot into the AWS account, if there are vulnerabilities or misconfigurations within that, then it's likely that you could obtain high privilege access to your cloud environments and to your cloud workloads before you even kind of reach the door of AWS and start doing things. So worth bearing in mind, like when you're thinking about the scope of this, that is something that's always worth bearing in mind. And then just one last thing about the EDR thing. So yes, if you're using infrastructure as a service workloads, if you've got your EC2s and there's that kind of, you often hear like kind of lift and shift. If your workloads are in the cloud and you're using virtual machines, there, by all means, get your endpoint detection and response, get the other security controls that you may have at your disposal on those devices to make sure that you're covered from kind of everything that you're provided with on-prem. The important things to consider, I think, are if those hosts are ephemeral. So if you're using EC2s that are auto-scaling, or they're kind of torn down and spun up in some reasonable frequency, make sure that your EDR provider and indeed your processes are capable of dealing with that. Is there going to be any issues with the EDR kind of pinging back home to its whether that's a kind of a cloud appliance or an on-premise appliance, wherever it may be? Is there going to be any issues there when it comes to that kind of re-registering each time the payload the workload comes back up? And just on that point as well, the connectivity itself, if you're using kind of a segregated part of your cloud infrastructure that maybe doesn't have the internet connectivity you need, then is there things that you need to be doing there to make that that security product kind of work for you? And then lastly, kind of, are there cloud native attack types there that you should be thinking about? Can you do more with your EDR or indeed any other security product to cater for those attacks that may not be something that you have coverage for or need to have coverage for on premise? So moving into reconnaissance then. So let's say we've come across our access keys in whichever way you care to choose from what we've just discussed. Ultimately, just like in any other environment, we need to understand who we are. We need to understand what we can access, and indeed we need to understand what we could access. And the distinction I'm making there, I guess, is much the same as if you've dealt with offensive tooling like Bloodhound, for example. You'll see that there are attack paths that can kind of go over several hops. So that could be a case of obtaining access to the initial EC2. We find out that there's a role attached to that allows us to modify certain identity and access management or IAM privileges. Can we change that to increase our access and ultimately potentially take over the entire account? So that kind of thing is worth mentioning, because that construct certainly exists within cloud as well. So let's take a look at that in our first of our labs then. We'll look at initial access and reconnaissance. So right here, you can see I'm on the command line. As we've already kind of mentioned, much of what we're doing here interacts with the AWS APIs. And just the same, we can perform malicious activities using the AWS CLI to make those API requests. So the first thing I'm going to do here is take the API keys that were provided to me through the Terraform that we talked about already. They're already actually configured within my command line, so you can see the access key requirement, the secret access key requirement. We're going to be using US East 1 for all of this, just for simplicity. And then from there, we can do the get caller identity API call to see some details about the user that we've compromised here. So obviously we know who we are, but just for the sake of this, you can see some useful information here. So first thing to mention is we have an account ID. And we have the username. In this case, we're a user entity, so we can see the customer data management user is who we are. So they're both going to come in use later, as we'll see. But for now, we carry on. So we know that we're a customer data management user. Okay, so maybe let's try listing the user policy. So which policies are attached to our customer data management user? It's worth mentioning that actually this user has, as I've said, has been intentionally misconfigured. So we have elevated access to perform IAM API calls. And so this list user policies and indeed the next one are both going to be a result of that. So it's only the get caller identity that's actually going to be something you can do with any AWS access keys. But these two will hopefully show you right now kind of what we're dealing with when it comes to the permissions that have been assigned to this user. So we saw in the previous one that S3 access is the name of the policy that's attached to us. So if we go and take a look at that, immediately you can see some interesting stuff here. So we've got our data bucket. So this is our customer data. We can get object from there. So if we know the name of the object, we can go and request that and fetch it all. And then by then we basically exfiltrated the data. And then similarly, just pause a second, you can see that I can list buckets as well. Specifically, I can do a list all my buckets, which shows us every bucket in the AWS account. And then we have one specific list bucket. So we're allowed to list the contents of the data bucket, our customer data, as I've said. So which we'll see in a moment, there are two buckets that we have available to us, as we saw, the logging bucket and the customer data bucket, but only one of them we have the ability to list the contents of and indeed to get the objects from. And then most alarmingly, I guess, from a IAM perspective is this IAM star, which effectively means that we have the ability to reconfigure the identity and access management within our account. So we, as we'll see later, and indeed in the lab guides, you could potentially elevate your privileges to this and provision additional kind of capabilities to take over the account in its entirety. So kind of dangerous stuff. So once we've done that, then let's take a look at the logs we've produced. So we're in Athena now. So using the Terraform that we provided, you'll be provided with two tables that are kind of pre-configured within Athena, the CloudTrail logs and the S3 access logs, which we'll cover off in a second. So with Athena, we can make SQL queries against our data sources here, so all of the logs that have made their way into our S3 bucket. So within our F-Secure workshop database, we can then use a query something like this. So we're actually selecting a subset of the columns within the data, and we're going to look for all actions that were performed by the customer data management user, because obviously we know what we're looking for, and looking for those three API calls: the list user policies, the get user policy, and the get caller identity. So if we just take a look there, we can see all of those APIs have made their way, API calls have made their way into CloudTrail, and indeed we can see them now. And there's some interesting stuff here, right? So we can see the request parameters for each of those. So we've done our list user policies, for example. We can see, I'll just pause it a second. We can see exactly kind of what we've been looking for. So we can see what's assigned to us, and indeed we can go and get the contents of that S3 access policy. And something interesting, which we'll cover off in a bit more detail later, is this idea of a read-only tag that's part of the JSON blob that's provided with every event that goes into CloudTrail. So this read-only field allows us to filter, as you might expect with any other kind of SQL query, to filter on read-only events and events that are what you might consider kind of active interaction. And we'll see the effects of that and how we could use that effectively in the next lab. So I will pass over to Nick for some persistence.
Thanks, Alfie. Yeah, so persistence. We've got quite a few interesting things to talk about here, really, because when it comes to persistence in the cloud, you have an awful lot of options, really. You've got all of your legacy options when we're targeting virtual machines, or in some cases containers too, especially where they're long-lived. So all of your old Windows and Unix persistence mechanisms are probably still viable if the target is running like virtual machine-based workloads. But also, there's quite a wide range of control plane level persistence techniques that we could work with. So, looking at a few of those now, one of the most obvious that we're going to be looking at in this lab is actually around additional access keys and login profiles on a IAM user. So there's an IAM user already in the account. IAM users can have up to 2 sets of access keys configured. And so if the user that you're interested in only has one, you can simply configure a second, and that allows you to authenticate to the APIs as that user. And when we say login profile in the context of AWS, what we mean is the username and password that will allow someone to log into an AWS web console with that IAM user. So AWS maintains separate credentials for the APIs to the web console, and so those two things there are what are needed for the APIs and the web console respectively. That said, though, we can also do things like adding SSH keys to virtual machines in the account. We can adjust the security groups controlling all the different types of network access so that we can allow traffic in or out that shouldn't be. Maybe we've got an implant that we want to beacon out. We can also do things like deploy our own custom Lambda functions that serve as a shell inside the account, especially if we assign those some quite interesting permissions. There's a lot of options there, but we're going to stick with the basics here for now, and we're going to look at the access keys and login profile, as I say. So let's take a look at this lab. So we're going to use Pacu for this, which is sort of a Metasploit for AWS in many ways, if you've not come across it, developed by Rhino Security Labs. And so what we're going to do here is just configure the access keys that we had from the previous lab. This will allow us to start working with AWS and give Pacu a set of initial credentials that it can use in order to perform the two persistence techniques that we're actually going to execute here. So now that we have the access keys configured, what we're now going to do is make use of the IAM backdoor user keys persistence mechanism here that Pacu comes with. And so what this does is allow us to add an AWS API key to a given user in the account, as I mentioned before. So this will often fail if you've already got two access keys configured, or it will always fail if you have two configured. So if you get an error trying to do this and you've already done it once, that's probably why. But here you essentially just pass in the username for the user you're interested in. In this case, we're going to do the customer data management user as before. And we'll see now that we have an access key ID, a secret access key for that user. You're welcome to give these keys a go, by the way. Funnily enough, we deactivated them before the workshop. But now that we've got the user access keys configured, we're also going to add a login profile so that we can authenticate on the console. And as before, Pacu has a IAM backdoor user's password module for doing this. And so again, we just pass in the usernames that we're interested in. In this case, it's that same user as before, the customer data management user. And when we run this, what will happen is Pacu will reach out to AWS and generate a password and set it on the on that user. So now that we've got a ridiculously long password, you can see here we've got the account ID, which we previously got from the getCaller_identity API call. We've got the IAM user's username, and we've put the password in, and we now have access to the AWS console as that user. You can see there the user and the account details. Now, if we jump into security credentials for that user, you can see first off, we've actually got the API keys there. You can see were configured, well, when the video was run, but about when we did it. And then also you can see up the top that we have the, oh, no, it's not in that view. No, never mind. If you go into one of the other views for users, you have the login profile configured there as well, but we've not shown that in this demo. So if we now jump into Athena, let's take a look at the logs that were generated by this activity then. So the query we're going to run here is going to be looking for much the same as what we looked for last time. If the video actually plays. Oh, there we go. With the key difference here. With the key difference here now that we're also adding a check for read only equals false. And so when that query is run, which apparently PowerPoint's just not playing all the videos.
Yeah.
There we go. So that read only equals false means that we're only interested in write events rather than get, list, destroy, etc. And so you can see here we've got 3 and 2 for create access key and 1 for the console login. And most interestingly, you can see we've got different user agents. So that Boto 3 user agent is what comes with the default AWS Python library. That's what Boto 3 is. And so if you're using tools like Paku, that's typically the user agent it will come through as, whereas the console authentication has come through with a web browser user agent. And so while obviously user agent is far from a infallible detection technique, far from it, it is still quite useful against low sophistication attackers to get a feel for what they might be trying and how. So one of the reasons we did the filtering there based on whether the events were read-only or not is because, at least to start with, active interactions, as we're calling them here, or mutating events, as some people like to call them, events where something changes, we're adding, editing, deleting resources. These are generally an easier thing to detect on to start with, because they will give you higher fidelity things to work with, things that happen less often. Also, the other thing you find with AWS is that when you're using the console, it generates vast amounts of read events, because in order to populate the console, it makes lots and lots of API calls back to AWS, and this is purely just to load up that IAM user page that we noted before. It made all of those API calls, and so it's quite useful to filter those out initially. When you start looking at detections based on read-only events, looking for things like account enumeration and so on, again, we can filter the user agent to some degree because it's likely to come from console.amazon.aws.com if it is a console action. That said, obviously the attackers are aware of that, so maybe some of their activity slides under the radar because they changed their user agents, but an interesting little bit nonetheless. At that point, I'm going to pass on to Alfie for data exfiltration.
Yeah, nice one, thank you. So data exfil, as we've said, I think one of the, certainly, I guess probably the most common thing we're seeing at the moment is that crypto mining thing. So just taking keys, and the most immediate way to get some return on investment with those keys is to deploy crypto miners. And indeed, you'll see some findings in guard duty relating to that, whether that's doing an address lookup on a crypto mining exchange or something like that. So there is some coverage from that you might be afforded. But when it comes to data exfiltration, there's maybe of a less kind of smash and grab kind. Aside from our publicly exposed storage that kind of seems to be in the news a lot, it really depends on the workload that you are kind of looking after and how that's architected. For the purposes of this workshop, and in the interest of time, we're going to focus specifically on that S3 storage again, and focus on our data events and indeed the server access logs that are also produced certainly within our lab environment. So let's have a look if we can exfiltrate some of this customer data. So I'm returning again to the AWS command line, and here we are going to firstly, so the video runs this time. Is list the buckets that we have available. So this is leveraging that list all my buckets API privilege. So you can see there that we have two. Obviously, we expect that. And we can try and list the contents of that data bucket. So if we do that now, okay, we've got our customer data, customer A, B, and C. There's not too much data here. And then we can try, but we'll inevitably fail to list the contents of our logs bucket. So there we go, we can see access denied, and you can go and look for that in the labs, the actual access denied event itself. So just to confirm that, we can just look back at the user policy, just see that JSON blob that kind of confirms this. And just as you can see there, we have the ability to list specifically the contents of the data bucket, but only the data bucket and not the logging bucket. And we have that list all my buckets, which would have allowed us to see the logging bucket in the first place. So from there, we can use a sync command eventually. There we go. So just with this, simply we're going to provide the S3 bucket we're targeting and a local directory. And as we have the ability to get all the objects within that bucket, we can just enter that, and you can see that it downloads each of those and syncs it, as the terminology says, to our local directory. And then we can cat out all of the information there and see all of the super sensitive customer data that we've produced there. So let's turn our attention then to the logs that we can use against this. So how can we see people that are reading our sensitive data? It's worth mentioning in the lab guide that we go through this kind of a bit more of an extended way. So we actually escalate our privileges with IAM to the point where we can delete the customer records and put a ransom note in its place. But for the purpose of this, we're just going to download that data and see what we see firstly from CloudTrail. So within our lab environment, we have data events already configured. And so we are afforded the opportunity to look for the get object, at least event names, and the list objects with no prefix. So here we're looking through just a few of the columns in our CloudTrail logs, and just for simplicity, you can see I filtered based on that user agent for those 2 API calls. So if I just let that run, there we go. We can see obviously clear as they are list objects. Worth mentioning this again, this takes like 15-20 minutes to come through with CloudTrail, so there is some latency. If you're kind of refreshing Athena and expecting to see something, it might just be a bit of lag there. And then interestingly, we can see our get object APIs to get each of our customer data records. So worth mentioning there that we're not seeing a sync bucket or something of that kind. What we are seeing is a get object for each of the records that are within our bucket. So if you're doing some kind of targeted engineering or detection engineering based on a specific file, you can see exactly when that file was interacted with using these API kind of logs, rather than say just a sync bucket and having to infer that the file you're interested in was in the bucket at the right time and was a target of this. And there we go, we can see that there. And then if we turn our attention to the server access logs there, so just the same as we did with CloudTrail, we can do quite very similar things. So we can select a few of the columns there, provide our S3 access logs as a target, specify our bucket and the requester field as it is for the customer data management user. And then from there, we can take a look at some of the logs that's produced. I think it's kind of reasonable to say that this looks, as its name suggests, a lot like like a web server access log, and this is like a space delimited. If you look at the raw logs in your S3 bucket, you can see what that looks like. But that still provides us with much of the same, not all, but much of the same information there when it comes to the actual operations that are being carried out, the target objects, as they're called, the objects within that bucket that are being interacted with, and then there is a result field here that would suggest that those were 200s, and they did go through, and we did in fact exfiltrate those 3 files. So just to cover off when it comes to some of the differences there. So this table is taken from a Netscope blog on the difference between server access logging and data events or object level logging, as it's called. And you can see just a few things that are relevant here. I think the important thing is to say that, like, depending on your application, as in your detection application, one of these may be useful. So you don't really need both. They're kind of there's a lot of redundant information doing both. But things to mention: the quality of service. So there's not guaranteed delivery of events with server access logging. Object level logging or our data events can log to more places. So whereas server access solely goes to an S3 bucket, we could do some more things with data events. So we can send that to S3 indeed, but we could also see that within CloudTrail and use CloudWatch as well to make that happen. Not to say you can't do that with server access, but it's kind of essentially easier and less effort to do it with object level logging. And then we also get a ton more information. If you go and have a look at the kind of JSON blob within a single CloudTrail event, you'll see there's a lot of things there when it comes to the session information that you might want to use that can kind of allow you to more effectively pivot between the various data sources you might be using. And then bonus round, I'm going to pass back to Nick to talk about Leonidas.
Thanks, Alfie. So something extra we threw in here is a bit of a demo of an open source tool that I released last summer called LEONIDAS. And what LEONIDAS is a framework for simulating attacker actions in AWS right now. Hopefully Google Cloud and Azure sometime soon too. But think of it as Atomic Red Team or MITRE Caldera, things like this, for cloud, because most of them don't have a huge amount of support for cloud yet, or they certainly didn't when we were writing this. And essentially, you write short YAML test cases with typically sort of a line or 3 of Python in to execute the actual action, and then the framework bakes you a Lambda function that runs in AWS through a CI/CD pipeline and gives you a bunch of web endpoints that you can then hit to simulate various attacker activity. So what we're going to do is run the demo for our upcoming RSA talk, just to talk you through how some of this works and how we typically use it.
That's playing. I'm not sure if you have audio, Nick, if you want
to. So yeah, I'll just talk over the top of it. There is supposed to be some audio, but never mind. So this is Jupyter for those who aren't familiar with it, but essentially it's Python code embedded in a document format in a web browser. And so this is quite a good way of experimenting with various Python libraries. It's quite commonly used for threat hunting, but also here we're going to use it for LEONIDAS. So we configured the LEONIDAS API endpoint, and this is now printing out a list of the different test cases. And there's quite a nice variety there. We've got some persistence test cases. We've got some privilege escalation. I think there's also some discovery and some impact further up. But it's a nice mix, and we can construct an entire kill chain essentially off these test cases. So first off, this is LEONIDAS running get caller identity, and what you can see here is the app itself comes with a role. That role is given permissions according to the test cases you have configured on it, but it serves as a nice starting point. So first off, let's enumerate some CloudTrail. Let's see if we're being monitored. So hopefully in a second that will actually run. There we go. It's been a little while since I recorded the video, so I'm losing my timing slightly. But you can see there we've got a couple of CloudTrails, and so LEONIDAS has run the command for us and returned some data, and we can use that to work out, how we're being monitored. So then up next, we're going to add a persistence mechanism. This time around, we're going to add a user rather than modifying an existing one. So we're going to create a user called RSA user, and lo and behold, we've then got a new user created. We're going to then add some access keys like we did to that other user before, and that then you'll see there's a secret access key and access key in that JSON blob. We'll make use of those later, but for now we're also going to give it the administrator access role just to make sure everything else works. So now we've got these new user credentials that we've created, and so we can pass those as a credential block into LEONIDAS. So now instead of simulating as the LEONIDAS role, we're simulating using this new user that we just created by passing in the access key and secret access key that we created before. So now we're going to run the get caller identity function again, only this time you'll see that the ARM that we're coming back with is the RSA user that we created a moment ago. So we're now simulating from a different IAM entity than we were before. So let's have a look at the secrets. We're going to go steal some sensitive data. We can see there's a secret in the account. And next up, let's exfiltrate the contents of that secret, which here is just a fake API key that we've put in. But what we've done here is simulate an entire kill chain start to finish. We've landed, we've done some enumeration, we've put a persistence mechanism in, we've escalated our privileges, and from there we've switched to this persistence mechanism that we deployed and exfiltrated some sensitive data. So you can quite easily script up whole kill chains with it. It's quite a nice way of simulating attacker activity in AWS, really. But the other really powerful thing with it is that it actually generates some pretty good audit logs itself as to what's happening. So if we go over to the CloudWatch console now, this is the logs that LEONIDAS produces for every test case it executes. So you can see we've got the get caller identity call there. That's the CloudTrail enumeration one, adding our IAM user. You can see all the activity there, but then if we expand one of those out, you can see that not only does it log the request, i.e. who was it that made the call, what credentials were passed in, all of this, it also logs the results you get back, and you can take that and you can compare it against whatever's turned up in your scene, whatever alerts have fired, to verify that the things that you expected to trigger, the expected use cases or signals, were firing correctly. And in fact, if you were really feeling keen, you could probably take that data from your scene, that data coming out of LEONIDAS, and build yourself like a full-on continuous integration system for your detection capability and start flagging where your detections break.
Nice.
So now let's jump into response opportunities in the cloud. And so we talked a lot about detection here, but it's worth talking about response too, because the cloud brings some quite nice things to the table. So AWS comes with a ton of different security services, but the point where this really becomes powerful is where we then add in Lambda, serverless functions in AWS. So you can then feed the data coming out of guard duty, for instance, for findings it's raising, or config for changes to the account, into Lambda functions and react automatically to some sort of activity if we deem it malicious. So let's talk a bit about some of the automated responses we might want. You can do things like if we spot an EC2 instance dialing out to a known crypto mining pool, we can take the disk and memory snapshots there and then, while also firing off the alert to tell the SOC or the responders to come have a look. And by the time an analyst actually sits down and starts going through the event and triaging it, we can already have had the disk and memory snapshots ready. We can have done some initial analysis, file carving, and so on, and have that ready to present to the analyst where we when they sit down. Equally, we can do the same with automatically responding to anomalies in a Kubernetes cluster by pulling the relevant nodes out automatically and isolating them off somewhere for someone to look at later. And one tool worth looking at in this space is an open source project by Twilio called Sockless, so called because it's a serverless platform that they use as a SOC that does a lot of their automation for them. So even without that, though, let's say we've not gone as far as automating all of our response to everything. We also have this idea of API-driven containment. And so I've seen a few cases, it's not that often, but it does happen, where when faced with a hands-on keyboard attacker, it becomes a race against time to contain an attacker versus them responding and trying to maintain their access. So what you can do with all of these APIs that AWS provide is essentially script up your containment ready to go. And then when you're at the point where you want to initiate containment, you can run that script and complete all these actions on an automated basis faster than the attacker can respond, because it's happening at the speed of your script rather than a human typing, right? And so that's quite a powerful idea that I think we're going to see a lot more of in the cloud going forward. Lastly, you can redeploy on non-conformance. So what we mean by this is monitor the state of your environment for drift against a baseline or for things that you know are bad. If you know you don't use IAM users, then suddenly some IAM users turning up is probably a bad thing. Things like this. We can monitor for these and automatically redeploy the environment when bad things happen. And quite a few of our clients actually do what they call blue-green deployments anyway, where you tear down the old environment after you've deployed a new one, and you switch the DNS records over between the two. And so you can essentially do that for security as well. If you notice things are bad, that's fine. We deploy a new copy of the environment, move all the data over, and tear the old one down. So nice. To conclude then.
Nice. So yeah, I think we covered a few things there. I think first and probably most fundamentally, as the name of this workshop series, is how detection changes in the cloud. I think obviously there's some new log sources we've been talking about, but equally we've been talking about how we consume cloud services, so how those workloads could be ephemeral. Indeed, how we're not talking about virtual machines anymore. Potentially, we could be talking about an entirely kind of cloud native and serverless environment, in which case we need to adapt when it comes to our telemetry sources and indeed when it comes to our detection engineering. And then we played through that attack chain from the initial access with our access keys that were compromised for our customer data user. And then we've looked at what we can access there. We've installed persistence, an extra AWS access key added. And indeed, we added the logon profile as well, so we didn't even need the access keys anymore. And then also we looked at exfiltrating data with an S3, all the customer data within an S3 bucket, and we saw how cloud trial data events as well as server access logs could serve us well when it comes to highlighting that activity. And just to round out, just another mention for LEONIDAS, it's open source, available on GitHub now. So please go and have a look, have a play, contribute some additional test cases if you're interested. And as Nick says, at the moment it's AWS specific, but we are working on Azure and GCP as well. And just to mention as well that in the Q&A you'll see a link to Nick's forward CloudSec talk that talks about LEONIDAS in a bit more detail if you're interested in the ins and outs of it as well. And then finally, it's gone quite quick. We're on to our last workshop of the month. So we'll have Masande with us next week to go through some detection concepts within Azure. So hopefully you can join us for that. Registration is still open if you want to be a part of that one. And indeed, just with all the others, there'll be a recording, PDF, lab guides, all of the good stuff will be available after as well. But otherwise, that leads us to say thank you for joining. Thanks for the questions, and thank you as well to Jonathan, who's been in the Q&A answering some of them as well. And I hope to see you next week. Thanks, everyone.